everyone. Everybody in the room and everybody online. And I want to start by thanking the city of Chicago for bringing my hometown weather to make me feel at home. I don't know how you feel about it, but I find it pretty nice. My name is Pierre Roman. I'm a principal cloud advocate with Microsoft. I am a server hugger. I am an operation and infrastructure guy. I know how to spell AKS. But with me, luckily, I have Vinicius.
Hello, everyone. I'm Vinicius. I am not used to the code of 𝗏. It's a great pleasure to be here with you. And I used to be a server hugger, and now I run AKS and containers. So thanks for joining us. So the first thing I wanted to talk about is that this session is not about AI.
Really?
Most will get close to AI. The closest we'll get to AI is the headshots that you see here in the screen. All right?
Yes, those were AI generated.
So let's talk about what we're going to cover, and I want to take out of the way that we're going to have a lot of demos, so we have a lot of content to cover. We'll keep the pace going. So we're going to cover about why Kubernetes and why it's a trend. We're going to talk about how to get from VMs to containers, from containers then to Kubernetes, and then a quick view, a very brief view of how to monitor and operate a AKS cluster. All right? Now, I'm assuming, based on the title of the session, that most of you are running Windows Server today, are running VMs, you might be running Linux VMs as well, but you are not used to running containers and Kubernetes. So even if you've seen a session or content about Kubernetes, you might have noticed that it's usually focused on developers. So with that,
we are not going to cover K8's API servers. We're not going to cover internal components of AKS. We're not going to cover VS Code and develop application for containers. And we will not present from a developer's perspective. This is about operation of those workloads. So just a show of hands, who here actually runs AKS in their environment? Now get out. No, I'm just kidding. But all right, take it away, Vinicius.
All right, so for those of you just getting started with Kubernetes, the main message we want to convey today is that all the knowledge you built over the years running VMs, running Windows Server, running the infrastructure, that's transferable to containers and Kubernetes. However, there's a learning curve for learning Kubernetes and containers, and this session is right here. So we are at the very beginning of that learning curve. And we have 45 minutes already used, like 4 minutes already for this session. So we'll keep going, but just keep in mind that as you go back home, keep that learning going. We have a bunch of content online to help you. If you have questions, come talk to us. We're more than happy to help, but keep the learning going after the session as well. So let's start with why Kubernetes, containers and Kubernetes. And it all starts with the DevOps practices. So in the past few years, customers and companies have adopted DevOps practices to make the process of deploying applications easier and faster. Okay? So from your developer standpoint, they're going to develop the application.
You said we weren't going to talk about developers.
We are not going to cover that. But they are developing applications. They have their own environment. They're your open Visual Studio. That application sits then in a source control like Azure DevOps or GitHub. And then you have your DevOps pipelines that will automatically build the content of the application, all the assets, everything the application needs to run, store that in a repository like a container registry, to then be deployed in your production environment or your test environment, validate that everything works, deploy to production, connect to your database, and so on and so on. Now, of course, we also monitor, and based on those insights, we will provide feedback to the developer, they will enhance the application, and we start the cycle all over again. Now, this practice allows me to do that process much more easier, right? Now, from a role standpoint, this is where the developer wants to be. They want to be focusing on developing the application. Most of the developers that we talk to, they don't want to manage the operation side.
That's where I live.
Right. So there's some overlap. However, most of the developers, again, they don't want to be dealing with the production environment. So when they build the application in a container to run on Kubernetes, what they want to do is exactly what they have been doing over the years. Hand over the fence and let us run the infrastructure, right? However, in a DevOps practice, we do this in a more coordinated manner where there's some overlap in the middle, where we work together, make sure the application works, and then we go ahead and deploy, we monitor, we make sure that everything runs fine, all right?
Yes.
So when to use Kubernetes? When you have a highly developer-iterated application, developers are constantly updating and deploying new releases of the application. That's where Kubernetes is going to help. Now, Pierre here pointed out to me that I could do that with VMs.
I can.
Right?
Yes.
You can deploy a VM over and over. However, those are usually manual processes. And not only that, even if you automate the process.
You can automate it. There
Right.
are tools for that, and there are processes, so you can have a VM as an endpoint of your DevOps process, but it's a little bit more complicated to scale and a little more complicated to iterate really quickly.
Exactly. So, and even if you have to manage that entire VM, it's an entire operating system that you have to manage, you have to back up, you have to update, upgrade, and so on, right? So when you have a microservices architecture, can you run a microservice in a VM?
Yes, you can.
Of course you can, but it's an entire VM you have to manage, all right? When a container, we're going to talk about that, but it's essentially just the prepackage of the container that you need to deal with. If something goes wrong, you bring the container down, bring the new version up, and it's good to go.
It's more of the pet versus cattle approach.
Exactly. So systems requiring scaling up or down. So again, you can do that with a VM, but containers and Kubernetes make it much easier to scale up and down and also horizontally, right? So if you need to add more systems to it, it's much easier to do that. Now, the other thing is when not to use Kubernetes, which is an important point.
Whenever I can. Sorry.
So we're not saying that containers and Kubernetes are going to replace VMs. Actually, the opposite. There are scenarios that it doesn't make sense to use containers and Kubernetes. So when it's more complex to run Kubernetes and containers than running your application itself,
Because you don't want to have to build an infrastructure to manage an infrastructure, because now you've got two infrastructures to manage and so on, and they tell two friends and two.
Yep.
Yep.
So, and also in scenarios where you don't have or you don't need all that automation, you are going to deploy things manually, and if that's the best approach for the company and for that specific environment, keep doing that, okay?
Yes, because we all have environments and workloads that are not the type of workloads that you iterate on. Like your SAP, ERP type system is not something that you change rapidly.
Exactly.
Because those, by design, are meant to be stable.
Yep. So, you want to take it away?
Yep. So, once upon a time, we were server huggers. And then somebody told me, you need to virtualize your machine. And I said, over my dead body, you will have my server when you can pry it from my cold, dead hands. Some of you may remember that era. I grew and I was in the business when that happened. And I've remembered all those conversations with everyone saying, it's working just fine. Don't touch it. Why would I move it to a virtualized environment? I'm going to lose some control. And look at it today. How many of you are actually running bare metal servers? Show of hands. Okay, I'd say that's probably
For the right scenarios.
1-2%. And it probably in as you mentioned, very specific scenarios. So we are now all virtualized. What's the difference between a VM, or a server to a container? Virtualization isolates the VM from other VMs. We all know that. I'm not going to take you through this, or else you're going to throw me off the stage. Containers are the same thing, except we don't have to worry about the OS. We don't have to worry about all of that underlying infrastructure. So we isolate workloads or application from other workloads and application running on the same node or pod or cluster, depending on the nomenclature you want to use. So for virtual machine and containers, VMs solve for better hardware utilization. So if you've got a big machine and it's running at 5%, now you're putting a whole bunch of VMs on it, and now you're utilizing the investment that you've put into that hardware much more efficiently. But with container, you solve for portability. So you can move that quickly, you can respin it quickly. Again, like I mentioned, it's the cattle versus pet mentality. We can manage as a single instance when you're working at VM, or multiple instance if you're running in a scale set, but the building of that VM, the care that you've put into that VM is the same, versus containers that can be much better managed at scale. We care about our OS. Every month on Tuesday, we cuddle it, and we patch it, and we hope it comes back. And our applications are the same. With a container, we just make the update and build a new one. The old one disappears, the new one comes up, nothing, no skin off anybody's nose. So how do you build a virtual machine versus a container?
Yeah. We've been 10 minutes in.
We're 10 minutes in? Okay, go.
Time for a demo.
Hey?
Time for a demo, right?
Time for a demo.
All right. So let's talk about how we build a container. Let me go to the...
Show me.
So Pierre, we talked about how containers, you prepackage the application, right?
Yes.
So it means that it's reusable. You can go and reuse that container over and over. You can do that with a VM.
Yes,
right?
absolutely.
How do you do that?
Well, to package an application for deployment in a scale set, you take your VM and you patch it. Then you install your application. Then you configure it all. And then once you're done, you run sysprep to generalize that machine.
Sysprep, right?
Anybody else
here
do that?
ran sysprep once in a lifetime? Yeah? Okay.
3
Great.
times a week?
All right, so let's sysprep the container.
Okay, let's sysprep a container.
There's no sysprep in a container. All right? So the way you do it is, most likely you got a document from your developer.
Yes,
Nice
the build sheet? Yeah.
Yeah, saying like, install YIS, configure.NET, create a web page.
Yeah, the document we don't read.
Right. So that document you never read, it's now a script.
Oh, we do that too.
Right?
Yeah.
So
PowerShell and Bash and all kinds of different things.
So what you're seeing here in the screen, that's Visual Studio Code, by the way. Nice to meet you. It's essentially running the application, but I'm not going to touch that. You can look at the application here on the left-hand side. However, what I'm showing you is just the script that is going to build your container image that then can deploy new containers from. All right? So all I have here is a script that says, go to the repository where the IIS image for Windows Server 2022 is, create a new folder called sample, copy the content from the local machine or from whatever we are running this into inside of the container on that same folder, and then run some PowerShell scripts to deploy the application as a IIS web server.
That's pretty much the same PowerShell commands I use.
And it's exactly the same PowerShell command.
Okay.
All right? Now, I'm not going to lie. Most Docker files are not going to look like this. They're going to look something like this because they were built by the developer. So they have multi-stage. They have a lot of best practices. They have configuration from .NET. So what I'm saying here is that if you need to build a Docker file, you can think about the Docker file as your script to deploy the application. The same way you used to do, now you're doing a container with a Docker file, which is the file used by the engine of the container runtime to go and create a new container image to then start new containers.
And we've been doing that forever. We started out like BB scripts and then PowerShell scripts and all kinds of different scripts.
Yep. So the other thing is, we're going to show you some things that we usually, in the real life, we don't do manually. We automate things with DevOps pipelines, but I'm going to explain those in commands so you can see what's going on behind the scenes. When you start to automate things with DevOps pipelines, you're not going to use these commands that we're going to use, but it's important for you all to understand what they are doing when you go and you script that. So the first thing we're going to do is we're going to build the container. So I'm going to use a Docker build. I'm going to copy into here.
That's like our sysprep, right?
Right. Yep, exactly like sysprep. So it's running really fast here and really quick, simply because I already ran this. But essentially what it's doing is, if you look at what we had in the Docker file, it's running step by step, exactly as you would do, and creating the container image at the end based on all the configuration that you just provided as part of that Docker file. So, all right, it ran. The next step is to tag our container image, and I'm not going to do that in the interest of time, but essentially the Docker tag here is so you can push, which is a fancy name to say upload, my container from my local machine into a container registry. And being in a container registry, any other nodes can go and pull or download that container image to run locally, okay? So I tag the container image from my local image to the registry. I push the image, and then I can go ahead and run. Now, the one thing I wanted to notice here is the session count. So the application itself, one of the things about containers is you don't want a hard code configuration about the application into the application itself. Because if you are going to deploy in the testing environment and you have a database connection for the test database, you're going to use a connection string and a username and password. If you're going to deploy on a production environment, that's a different database with a different connection string, different username and password, right? So because we want everything to be reusable, that configuration is not inside of the container image, but the container image needs that information in order to run. To emulate that, my application here essentially says, when I launch, how many sessions are available for scheduling for the Ignite conference. So that's the information that I'm passing as an environment variable for the container. Every time I'm going to deploy, the information that the application needs to be deployed can be passed on for that particular deployment. So when I'm going to run this information here, or this container, it's going to create a new container. It's going to pass that the information is 400 sessions. Because I'm using my local machine, I am mapping ports between the local machine and the container. It's going to use that image. So if I go here and I say, open the port 8080, you can see here that we have 400 sessions available for being scheduled. Now, I'm going to use the same image, but provide a different information. So I'm going to go here. I'm going to select the same command. But in this case, what I'm going to do is I'm going to say 500 sessions and map to the port 8081. There you go. Now, if I open the same website, but with a different container, it says 500. Same application. All I did was change the information that was provided for the deployment time of that application. Can you do this with the VM? Yes, you can. It's much more complex. All right? So that's the beauty of the container. So Docker file to create the container image, put your container image in a repository, and then you can go and deploy. No information is hard-coded. You can pass that information at deployment time.
Okay, so you got me. You got me. It's a little simpler than like doing all of this, the installation, the configuration manually, which we can also automate, and then doing a sysprep. But once I got my gold image, and I upload it somewhere, and then I can deploy it.
Exactly.
Yeah. But what about the other tasks I need to do?
Yeah, we're going to get there.
Okay.
So the first thing I want to talk about here is that all the commands I use there, Docker run, Docker something, they are part of the knowledge you already have. Right? So this slide, we're not going to go line by line, is essentially to say everything you are used to do on a daily basis has a correlation on the Docker and container side. All right? So as you build your knowledge on how to use container, everything you learned over the years is going to be reused. So now that we talked about containers, let's talk about Kubernetes. okay?
Oh, that's where it gets complicated, right?
That's where it gets complicated. And that's the reason why we're going to do this a little bit different. So, like we said at the beginning, every presentation of Kubernetes talks about the Kubernetes API, how to deploy a Kubernetes cluster. We're not going to talk about that now. We're going to talk about you as a user of Kubernetes, how does that work? So we talked about the container, right, which is your application running. In Kubernetes, you have your container running. Kubernetes is going to take care of that for you. But in Kubernetes, we have a concept called pod. And the pod is an abstraction of the container for Kubernetes, because when you run an application, your developer might have configured a container to run the application and a sidecar, which is another container that runs side by side
What is that?
to get metrics for how the application runs.
Is it like running two VMs side by side and one is doing one thing, one's doing the other?
Exactly. But they all operate for the same application.
Oh, yeah, I get it.
And then we have another concept where we wrap the pod, so you don't manage pods specifically. Essentially, in order for you to get your application deployed, you have what we call a deployment. Now, a deployment is just a way for Kubernetes to know that everything that goes inside of that deployment relates to the same application. So
like a resource
if you need
group.
to, exactly.
Okay.
So if you need to scale that up to 2, 10, 50, 100 pods, you can do that by telling the deployment to do that, rather than configuring pod by pod.
So it's like the logical grouping of everything that works together for the application to run.
Exactly. So everything in Kubernetes is what we call a YAML specification. So this is the specification for my application. And essentially, the reason you want to do this is just like the Docker file, you want to make this reusable. So I can take the same specification, change the configuration for all the environments that I have, and it's going to run exactly the same way.
But I can do this for VMs, because I can deploy using a script, a template, a bicep file, a Terraform script that will have all that information in it.
Yep. The difference here is that we're treating the application as a single thing. So for example, if I need to say this application now goes from 2 replicas to 3 for 1 replica to 2 replicas or 3 or more, the deployment is going to then be scaled up or down.
Yeah, and we can do that too. But you have to set up your gold image. Then you have like the one VM, and then you can scale up to 2 or 3, and then you can scale back down.
Yep. The difference here is that we're dealing with a container that I don't have to deal with the operating system, and I can use from the repository that I have pushed my container image from my developer.
Okay.
Now, the other thing is each of the containers will get an IP address, right? What you don't want to do is you don't want to access that IP address directly, because if the pod goes down, then you can't access that. So what we do in Kubernetes, we create a service in front of every deployment. So you have a load balancer for all the pods that are sitting behind it, right? So what happens here is that if I scale up, if I scale down, my IP address for the load balancer will be for the service. Every time I hit the service hit the pod. If the pod is removed, the service stops using or sending traffic to that specific pod.
And that's like our virtual network switch on our virtualization platform of choice or in Azure.
In fact, when you start using AKS, you'll see that we actually have a node that is essentially a VM that runs the deployments, run the container, and then it uses exactly the same technology that Azure uses for VMs.
Okay, so my skills at managing that layer in my VM environment, wherever it may be, transfer very well into this. Okay.
So again, everything in Kubernetes is a YAML specification. So here you have the example of the service. It's a load balancer. It's opening the port 80. Could be opening any other port or the port 443, depending on the traffic. And then we have what we call a namespace. And the namespace is a way for you as someone deploying that workload to say, these are the folks that are authorized to actually access this based on our back, right? So if you need to give access to Pierre, you can give access to Pierre to the namespace XYZ. And then if you need to give access to Vinicius to another namespace, you can do that by namespace.
Which in Azure are the same skills if you want to give access to a scale set. Through RBAC, where you have access to contributor, you have access to reader or something else.
Exactly. Now, there are other components. We're not going to cover all of them, but for the sake of our demonstration, one of the things we're going to do is we're going to use the example that I used before. So if you have, for example, a connection string for the database, or if you have a username and password, you have two types of resources in Kubernetes. The first one is the config map.
We mentioned earlier we weren't going to hard code username and passwords.
Yeah, exactly. So if I'm not going to put the configuration about the username and password inside of the container, I need to put it somewhere else, right? Specifically for the username and password, I want to put that in a secure location, right?
Yeah, so that could be like Key Vault.
Azure Key Vault. Kubernetes has its own secret management you can use, or you can use Azure Key Vault, or you can use even a third party and other kinds of places or storage mechanisms for secure information.
Okay, so I already know how to manage that part, so okay, that works.
Great. So config map is the other one for things like the connection string for the database or other information that is not secret, all right? And then, again, the main thing about all of this, why we do all of this, is because if I have to deploy this for my development and testing environment, I want to have a configuration. If I have my production environment, I want to have a different configuration, right? So let's take a look at how we build a YAML specification. I thought that I was going to, I should bring Copilot in Azure, but I said that we were not going to talk about AI.
Well, I think we should, because YAML is one of those things that if one space will kind of like mess it up.
Yep. So I'm not going to bring necessarily Copilot in Azure right now. I can talk about it later. But essentially, if you have issues using a YAML specification, the one thing I want to call out here is that Copilot in Azure can help you understand what an YAML specification is, how to build one, explain what's going on, or fix issues in your YAML specification.
So
now,
if you're getting a YAML configuration from your development team and it's like 100 lines or 150 lines, because it's a large, complicated application, you can feed it into Copilot in Azure and say, explain this to me.
Yep. Or the other scenario that I like to talk about is if you are a consultant, sometimes you are called into an environment that you did not deploy, right? And you have to fix something that someone else did.
Somebody else's code.
Yep. So this is a great opportunity as well to use Copilot to explain what's in the YAML specification so you know what's going on. So with that said, this is my YAML specification. It essentially says, go use that image that we uploaded or pushed to the container registry. This is the port that needs to be open. This is how much hardware this container is going to use. And this is the information, just like on the Docker run command that we ran. This is the information saying, go check the session count in my config map. All right? So this is the deployment itself. You can see here the kind is the deployment. Next, what I have here is the service. It's a load balancer pointing to the port 80. And I have the config map that says the session count is 500. I could deploy these three components separately as its own YAML file, or I can put them all together separated by the 3 dashes here and in a single YAML file. It's up to you how you want to do it. So with that said, what I'm going to do is I'm going to go ahead and I'm going to deploy this application. I'm going to use the kubectl apply. So quick mention about kubectl. It's kubectl, not kubectl or kubecontrol. There's two.
But that's so much cuter.
Huh?
But it's so much cuter.
Yeah, there's two ways of looking at kubectl. The one is kubectl or being wrong.
Oh, okay.
So with that said, I'm going to go ahead and create my resources here. So it created a deployment, it created a service, it created a config map. It's all good. I can go to the Azure portal, click workloads. I can filter the namespace. It's bringing me my deployment here. And I can look down here. I have the pod, and it's already running. All right? So I'm going to stop here for now. I'm going to go back to the presentation. Because the next part here is to talk about Kubernetes from a sysadmin standpoint. So now you are going to manage that as a cluster, okay? So
Oh, I do clusters.
you use clusters.
Oh, yeah, yeah.
Like these ones,
Yes.
right?
Oh, that reminds me of TechNet. Oh, that is TechNet.
That is TechNet. So if you've been deploying clusters, Windows Server clusters over the years, the main thing that is going to be changing here is that you know about quorum, you know about split brain scenarios, how Windows Server clusters deal with that, right? So Kubernetes, we have the concept of the master and worker nodes. So the master nodes are the nodes that essentially say to the worker nodes how to operate, and is the cluster, is the server or the node in your cluster that you connect to, all right? So starting with the worker node, the first thing we want to talk about here are the pods. This is running inside of a work node. You might have multiple deployments, multiple applications running on the node. All of that run because you have a container runtime on that node, and that's a worker node. Now, there are two components that are important for you to know. The first one is kubelet. So kubelet is the component on the worker node that the master will talk to and say, go run this workload. The other one is the kube proxy. And the kube proxy is essentially the component for the pods to know how to communicate with each other and talk to the internet and go talk outside of the node itself.
Which is like when I put a load balancer in front of my cluster.
It's your virtual switch, if you will.
My virtual switch.
Yep.
Okay. So those skills confirmed.
Now, the master node has a lot of other components that, as I mentioned, we're not going to talk about. If you want to know more, I highly encourage you to look at those. The main thing I want to call out here, kubectl talks to the API server. The Azure portal talks to the API server. So the way you access your cluster is through the API server, which is a component on the master node. Now, of course, that talks to the kubelet. You can have multiple worker nodes, and that's your essential or very high-level overview on what the architecture of Kubernetes clusters look like. Now, one of the things you might want to consider is running on AKS, because AKS takes the management of that infrastructure a little bit out of your hands, and we manage that for you. So it's much easier to get started with Kubernetes when you have a managed Kubernetes system. So the master node and some of the components in the worker node, it's Microsoft responsibility. The running of the worker node and the applications and everything that runs on it, it's your responsibility.
But I can run my VM clusters on-prem.
You can. We have AKS on premises, or you can deploy Kubernetes on premises as well. It's a matter of how much you want to offload from your responsibility into Microsoft responsibility.
Okay.
All right, so let's take a look at how we deploy something to AKS. I already did with the kubectl command, but let's take a look at the application running now. So if I look here, going back to the service, I have the workload with the deployment. If I look at the configuration here, and I filter for the Ignite demo, I can see that I have my config map for the Ignite demo,
yep.
And I have the service filtered by the namespace. So if I open this up, I will see exactly the same application, or I hope it works. There you go. Now saying that I have 500 sessions available for scheduling. So if I look back at my config map here, that's what it says. It says 500. So if I change this one to 400 and save, I can go back here. I can say kubectl apply again. I don't need to deploy, I don't need to delete anything. I'm just going to reapply the same specification that I already had. So I'm going to go over. The deployment isn't changed. The service isn't changed, but the config map has changed, so has been configured. So now, if I run the get pods, you can see, well, I didn't even have time to actually show you. So essentially what happened here is that we had a pod running with the configuration. So what Kubernetes did was, oh, actually, it didn't start yet. I'm going to get there. So I have a pod running with the old configuration, right? So now I'm going to run a command saying kubectl rollout restart. And what this is going to do is it's going to tell Kubernetes to check if there are changes on the config map, which there is, and restart the pod that needs to be restarted. So I'm going to go ahead, run. If I run the kubectl get pods, you can see that now I have the old container still running. I have a new one being created. And if I run again, it deleted the old one and now created the new one. Now,
that is a little quicker than shutting down a VM.
right? So if I just update here, you can see that now we have 400 sessions available. So it was much quicker.
Yes,
than
yes,
redeploying.
I will give you that. It was much quicker.
Right? So again,
Still like my VMs.
and you should. You continue to use your VMs for the scenarios that make sense. But when your developer comes in and tells you that you need to manage now your Kubernetes environment, now
Well,
you
I
what
know
to
my
do.
skills will transfer.
Exactly.
Okay.
All right. So with that, I'm going to go back to the presentation just because we still have to take a look at the operations.
Whoa. This is where I live.
Yes.
That
You want to take it over?
operations. Yeah, sure.
All right.
Okay. We all have to manage our environment, like workflows and workloads and VMs and networking and firewalls and security. And so we have logs and we have metrics that we have to connect to and basically collect and then visualize. So with AKS, I know that part. We can do exactly the same. And I will actually, why don't I just show you?
Yep. Let's go.
So if I'm looking at my machine there, I'm looking at a VM. It's a VM that we just created. There's not much running in it. But if I want to connect to it, it's the same thing. But if I want to monitor it, because this is what we're talking about here, I have my insights. So I can go in here, and I can enable it. So it will put in an agent. It'll connect that agent to a log analytics workspace. It will start collecting whatever data I tell it. You can configure how much of that data you collect and which metrics you collect. And I will say that on that one, we have to be careful as to how much data we collect, because we actually pay for the space that data is collected. But I have my alerts, so I control my alerts the same way, and I have my metrics that are all of the CPU metrics, disk metrics, network metrics. I got all that.
Yep.
Yeah. So that's on a VM.
You want to see that in Kubernetes?
Yeah, I'm going to show you now. I kind of played with it a little bit ahead because I wanted to make sure that you weren't pulling a fast one on me. So I got to my cluster here. It's the same cluster that you deployed, or it says one like it, because I used your code and I just deployed it into another resource group, because it's fast and portable. And now I go to my insight. Oh, this one is already running. Let's go to the one that's not running, because this is kind of a cooking show. So I go to my insights on the one that's not running, and I want to enable or configure my monitoring. So I get container insights, which is the same as what we would do with the VM insight. But I also have access to manage Prometheus and manage Grafana. So those two things together do what insights do. Prometheus collects all the logs and the metrics, configured the way you want them, what metrics you're going to collect, what logs you're going to collect. So if you've got your own application logs that are built into your application, you can tell it exactly how to get those logs and also how to parse them so that it can understand them. Grafana will take that data, and based on how you configure it, will visualize that data. So it'll give you a graph or CPU graph, resource graph, whatever, into something like pretty pictures that you can show management. Management likes pretty pictures.
And graphs.
And graphs. So why don't I do that instead? So I'm going to enable Prometheus, enable container logs. It's already done. I'm going to enable metrics. I'm going to go to advanced setting. I have to point it to a log analytics workspace.
Just like the VM.
Just like a VM. And I manage that workspace just like a VM. But I can use that, and I can basically make them separate. So I'm going to have one for Prometheus, one for Grafana, and one for Insights, and hit Configure. And it goes out and installs the bits that it needs within the AKS cluster and the infrastructure that we've deployed, and it'll start collecting data. Now, once it's collected the data, which is the one I was at earlier, under Insight, I see the info about my cluster. I see the info about my nodes, even though I didn't know what a node was before this session. I see the controllers and the containers that are in it. I can go to metrics, and just like we saw on the VM, I have my cluster metrics, but I have my node metrics, node preview, CPU, disk, memory usage, network usage, everything that we were doing with the VM, all of those skills that I've accumulated and all of those workflows that I've set up to manage workloads that are working in a clustered scale set or on a single VM or even in a single machine under the desk in your office that is connected. Now those skills and those alerts and all of the knowledge that you've gained transfer seamlessly. So there's not really anything for me to be scared of.
Yeah, the thing here is that you will build the dashboard that works for you and for your environment and for your needs. But the usage of the monitoring portion here is exactly the same that you're used to.
Yeah, and we talked about Prometheus and Grafana. We have the Prometheus visualization here, and we have the Grafana visualization here.
Yep.
I haven't configured it, so I'm not going to show it.
So let me just quickly move to this one. I forgot to give Pierre access to the Grafana dashboard, but essentially that's what it looks like.
So role-based access control is also same kind of skills?
Yep, exactly.
All right.
So you have the metrics that are used to, right? So this is the cluster utilization. I have node level, I have pod level, I have application level. It depends on what you need and how we want to configure that. The one thing I'm going to call out here is that in partnership with your developers, you might want to make sure that they have instrumented the application in a way that you can see those metrics and put it and print it in the dashboard that you're going to build for your own company and your own environment. All right?
Outstanding. No, that was it.
That was it, right?
That was it. I'm already deployed.
All right, so let's go back here. All right, folks, so takeaways from the session. So VMs and containers, they serve different purposes. Containers and Kubernetes are not going to replace VMs. They serve different purposes. It's important for you to know when to use each. So if it makes sense to continue to use VMs, keep doing VMs. As someone managing the infrastructure, it's important for you to know how to operate and how to manage a Kubernetes environment. Your knowledge of VMs will be transferable to running those workloads. Everything you learn over the years is applicable. And by the way, that workloads still run on DNS. It's always DNS, right? So those errors that you've seen over the years will continue to happen because the infrastructure is still the same. Once it's out of the container, it's networking, right? Managed Kubernetes reduces the barrier of entry. So in order to get started and get your environment running, consider using AKS rather than building your Kubernetes environment as VMs in Azure or on premises, all right? Quick link here to join the AKS community. This link has a bunch of information. We will be building more and more entry-level content as well. So I encourage you to take a look at this.
Yeah, I might do that now.
Yeah, right?
Just because I got a lot to learn.
Yeah. So this final slide has nothing to do with the session. It's just to create an emotional connection so we get a better evaluation. Thank you, folks.